Hello, welcome back. We have yet another series of talks, and the first one would be user centricity, beginning with the first keystroke by two folks from Otto, Gilke and Tobias Kässmann. So you're welcome.
Hello, yes, okay, you can hear me. Welcome to our talk about user centricity, beginning with the first keystroke. So this is Tom, I'm Tobias, and we are both part of Team Squirrel, which is completely responsible for the autosuggest on AutoDE. So I hope that everyone knows what an autosuggest is. So this is a screenshot of our website, and together with our team, we are completely responsible from end to end for the autosuggest. So that means in the end, we have front-end developers, we have back-end developers, infrastructure guys, product managers in our team. And this is pretty cool because every feature we would like to implement, we can implement completely in our own team. And this also means we are not blocked by any other team. So this is pretty cool. And you might ask, so what did I hear it right? There's a whole team completely responsible for the autosuggest. This is such a small feature. And yes, you're completely right. You heard it right. So the autosuggest is pretty important in the whole customer journey. So when the user starts and on the front page, he will can be influenced in a positive or negative way by an autosuggest. And this is something that we've also saw in our metrics and how we measure our the performance or how the users interacting with the website on AutoDE. And the name is called like user centricity, beginning with the first keystroke. And what about user centricity? So we in our team, we as the autosuggest team for AutoDE, we are implementing all features based on data. We evaluate every feature based on data, and we are doing a lot of data analysis to find out where the problems are from the view of the customer. And this is a pretty cool thing. And you're gonna see some features which we found out directly after we invested into some data analysis. We in our team, we have a vision, and the vision is your answer is just one step ahead. And that means we would like to provide the best answer on the first, let's say on the first result in the autosuggest. But yeah, this was the introduction. 1.5 years, so we started with our team, and we first created some baseline feature. We took over the suggest from another team. That was pretty cool for us to start with a small feature which can be removed completely out from another team. And we started to create some baseline features. And I don't know if everyone knows how a very basic autosuggest works. Usually it's just a mix of prefix matching. So when the user starts to type in with a P, then you will have some results like PlayStation, pullover, pool, polo shirt, whatever. And then you need to rank these results. And what you can also add there is, for example, in spell check. So there's a German brand which is nearly impossible to write correctly. But as a very first simple approach, you can add some spell checking there. So let's start with a customer journey on AutoDE. We thought about some initial interaction with the autosuggest. So the cool thing on AutoDE is that every customer who clicks inside the search box is the customer for us as a team, and this is a lot. So even if the customer knows or he's looking for a very specific product, this is our customer, and also all the customers who just would like to get inspired by some things. And this is the first feature we brought live, I think 1.5 years ago. This is a feature which is called the empty state. So for the users who would like to get inspired, we are suggesting some training queries. Very simple technical implementation, or the effort was very low. But we already saw an impact on orders, and we also had an impact on add to wishlist and basket. So first feature done, pretty cool, already impact proved, nice. Go to the next feature. We implemented a feature that is called the search history. So we are storing, if the user X cookie banner, we are storing the search history inside the browser. And then on the next day, if he comes back, he sees the search queries. And this is also very handy. The technical effort was medium. We also saw that the effort reduced a lot. And the impact on orders was much more than the empty state. So this is pretty, and why is this maybe the case? This is maybe some kind of personalization. So because these are queries that the user already typed in, and he might come back and we'll check it again if the results are still the same, or if the product is on sale now, so on and so forth. So next feature we've implemented is, let's say, Keystroke 5. And you here in these two screenshots, you're just seeing a very slightly different. This feature was also pretty nice because in the old days, we just never thought about that, about one white space at the end of a query. We don't thought, okay, this couldn't be important. But yes, we did an online experiment. We changed only one line of code, which was from the technical effort side, very, very simple. And we thought about, okay, the user gives us here a context. He said, okay, I would like to write another word. I would like to add another word at the end of the query. And we thought, okay, this could be worth an experiment. And we, again, found out less effort, more relevant suggestions for the user. And we increased the responsiveness. What does this mean? So the suggestions which we show to the user are changing. And this is some kind of a responsiveness. And also, again, the suggest usage increased. So we are comparing here in suggest usage the relation of how much is the user using an autosuggest in comparison to doing a search without using suggest. So very simple feature, deployed to production, everything fine. So the next feature is a feature which we found out during an analysis. So we analyzed how the user is interacting with our autosuggest. We take a deep look into the data, we analyze some sessions, and we found out that in most of the cases, the user is adding some characters at the end of a query. And their prefix matching works pretty good. But we also found out that on keystroke level, more than 10% of the user are moving the cursor from the end of a query to the middle of the query or wherever inside the query. We are calling this feature an infix search. And this is pretty cool because you cannot do prefix matching anymore. And this was a complete new challenge to us. We thought about it, then we found a very simple solution to that by adding just rephrasing a query of how we are querying our data store and just adding a regex, a regular expression there. And we saw in our queries, or we saw in our analysis, that users are always removing some characters here and there or adding some characters in the middle of the query. And in the end, after we brought this feature into an experiment, we saw that keystrokes were reduced because we are suggesting something. We are suggesting much more, even the user starts to type in the middle of the query. So keystrokes reduced, increased responsiveness again, suggest usage also increased. And the technical effort was very simple, just rephrasing the query of how we're querying our data store. What we also did is that we invested a lot in spell checking. So we did some iterations where we added clustering. So in autosuggest, you always challenges of, okay, PS5 or PlayStation 5, it is the same search. And we are clustering, we are collapsing them together. So these are the features we implemented in the past in the past 1.5 years. And during that time, we also had some infrastructural enablers that pretty helped us to, for example, bring A/B tests or online tests live to customer. In our backend, we've divided our architecture into 2 layers. First, a tech and distribution layer, and then we have a business layer here. Here, that tech and distribution layer is in service that is only there for redirecting some requests to this or that version of an autosuggest. And So that means in the end, we are able to pretty fast spin up a new instance of a suggest, which is a completely environment, an own environment, and try things out. And this is in a matter of time, it's just 15 minutes, which will take us this. And the distribution layer is only there to redirect these requests. And we also added some graceful degradation stuff. So that means if we have a version of a suggest B here in that example that did not answer time, or it cannot answer in any case because we're doing some weird stuff there, then it will fall back to suggest A, which is our main suggest, let's say. And even if the suggest A does not answer, we are providing the user a fallback. So a very static fallback list. So we are also measuring a lot of metrics here and there. This was a huge enabler on the infrastructural side. We also added a lot of measurability. We are measuring a lot of technical metrics. We added visibility, so know how your system is being used, know how your service is being used. And we invested also a lot into infrastructure. We invested into an infrastructure that is built to scale. So we have a very low latency on our services, which is a requirement to our autosuggest because you react on every keystroke to the customer. And what was also a very huge enabler for us was that we switched our data store to Vespa AI. So you know that architecture overview which we had, so the tech and distribution layer, the business layer, and below that we have the data store, which is in our case Vespa AI, and this helped us for the next step, which is machine learning.
Hello, can you all hear me? Yes, beautiful. So now Toby showed you a lot of quite technically simple feature. Like this? Like this? Ah, oh. Okay, so you heard from Toby that we built a lot of quite straightforward features. So the technical implementations sometimes were like really basically no effort. And now we had a status quo for every keystroke step that the user could do. And now we thought, how can we improve the setup that we already have? And we decided that we would like to try out what we can achieve with machine learning, but in a very simple way. And what we found are two applications in our suggest, and I will cover them right now, starting with re-ranking. So we wanted to have a feature for every keystroke. And our goal was that we have a list of suggestions, and we want to move the one suggestion that is really the best one for this user to the top of the list, so that it's closer to their field of view and they can really easily access it. So in a bit more detail, the selection process of the suggestions would look like this. So first you select the ones that you want to show to your user. Then we have some basic ranking. And afterwards, we re-rank the top ones from the basic ranking with a machine learning model. And then at the end, the really best one is at the first position. So as an example, we could have a user with such a history. You see that this user is interested in Herren. Herren is clothing for males in this example. And then reordering the suggest list would look like this. On the very left, you see the suggestions that you would get without any re-ranking. And the important part here is that in the top green square, you see there's clothing for females. And at the bottom, there's clothing for males. And after applying our re-ranking with the model, based on this history that the user had, you see that the clothing for Herren, so for males and females, switch places because we figure out, okay, this user seems to be interested in clothing for male people. From this feature, we saw that the suggest usage greatly increased. Our users didn't have to type their queries out. They rather really chose to use our suggestions. We also saw that they click more at the top of the list, which is really good for us because that's basically what we wanted to achieve. We wanted to move their suggestion to the top. In the end, this also saved effort for the customers. This is measured by us by looking at the keystrokes. So if the user has to type less keystrokes until they click, then they had less effort. And there we saw that we had a great improvement, possibly because the suggestion they like is more closer to their field of view, which is on the position where they type. But the technical effort is really high. This is just an overview. I will not go into detail, but the top that you see there is kind of a standard model training pipeline. So you always have a data source. In our case, it's the click stream. Then you have some pre-processing steps where you have to format the data. You really need to make sure I only use the opt-in data of the people who say, hey, I want such a feature. You have to clean up the data. And then the big chunk is the feature calculation. So you need to decide what features do I need and which ones perform best. And then you have to train a model, which is computational, a really high effort. But out of that, we generate a light GBM model in our case, which works really good for re-ranking. And we plug it into the infrastructure that Tobi started to mention. So we have the Vespa running there, and plugging in the model is basically just a few lines of configuration. And at the end of the pipeline, you always have some evaluation steps. So you want to make sure that the model that you want to put into an A/B test is kind of good, right? So we have some offline metrics beforehand that give us a hint if this model is worth to try out in an A/B test, or if we would break everything by trying it out. So that's the re-ranking feature. And the most recent feature that we were building is targeted to retrieval. So what we now covered are a lot of features with short inputs or like medium size. So the average amount of keystrokes that we have is like 9. But what we also get is a more natural language queries. So especially from speech to text, or right now, like everyone heard it, ChatGPT, Bard, all those tools, they understand your natural language. So they kind of seem to know what you want to say with the human language. So we expected that maybe in the future, we will also get more of those human-like queries. And we wanted to figure out how we can solve this. Because in the status quo, sometimes we just don't show anything. So the idea in a bit more detail, we want to first apply prefix matching. If this is not successful, meaning we don't find enough, then we do the things, the spell checking. So basically what Tobi mentioned already, just trying to figure out what you wanted to type. Maybe you just missed the key. And if all of those are not working, then in our first iteration, we just used a BERT model and applied it. And the application basically is vector search. So every suggestion gets embedded by the model. Then you create a vector out of it. Then you do the same thing with the query while you are getting the request from the user. And then you have a huge vector space of all the possible suggestions and the one vector that is your user query. And then you find the nearest neighbors in those space, and those are the suggestions that match the input. And we just tried it out and found that for such a natural language query, it was really good in figuring out that t-shirt is exactly the thing that should be suggested here. This was a 0 hit, right? Because prefix matching is really not helping you anymore. Spell check also just at the end of what we can do with our previous features. Cool thing is that the model that we picked was trained for English text. And accidentally, we enabled the feature of translation because our suggestions are all German and the input is English, but somehow the model is still able to connect it. So in the results, we saw a huge impact on suggest usage, obviously because there was nothing before, right? And now you had suggestions, but we also saw that users thought something afterwards. So it seems that the suggestions that the model retrieved kind of fitted to the goal that the users were trying to reach with the query, because otherwise they wouldn't have bought anything. We now basically don't have any 0 hits anymore, and the technical effort was not extremely high. With our setup, it was extremely low. So the whole thing was like 20 lines of really just configuration, and then it was up and running during one morning. This allowed us to do a few test iterations. I will just briefly skip over them so that you kind of heard some models that maybe you could try out. For us, the E5 Small is currently working best, but the biggest just learning we had from that was that it was really easy to try out multiple models and that it's worth it to try them out and see what works best. Now I will close with kind of more meta level. So what makes this possible? Because maybe you think like, hey, cool, there are so many features, and now you want to figure out how can you and your team build something like that. And we want to tell you some enablers that we had. So first of all, owning our whole vertical, meaning the whole front end up to the very end of the back end, really allowed us to build a lot of features. We have direct connection to the history because it's from us. We have a direct connection to the search box because it's also from us. So we can control that, for example, we get a request when the user didn't type anything. This would be possible without a front end. Also, we have always the question of will it scale. In this case, it basically means, are we fast enough so that we have enough headroom for more features? Because if you want to answer for every keystroke, you have to be insanely fast. The users will recognize everything. Visibility is key, and with visibility, we mean not only like measuring your KPI metrics, but also how users interact with your feature. Really explicitly, don't track the users, but track the usage of your feature. In our case, it's what input queries do we get. With that, we figured out that infix match is something that the users seem to need. Also, the stuff that Toby described with our distribution service makes testing easy and safe, which for us was a huge enabler to get speed. And you need team enablers. So you really need to invest into knowledge sharing. For us, it was a huge investment at the start, but now our team really is up to speed. Everyone can participate on the topics we work on. So this is always something you should be willing to do. We have space and time for innovation, meaning that all 2 weeks, we have one day where we can do what we want work-wise. So build the infix search in one day, include the bird model in one day. All of those features happen during this day. So give this space and time. It will really pay off in your team. Trust is huge, not only between developers, but between product people and the developers. Trust in your infrastructure. So you really need to see how the people in your team feel. Do they feel that they can trust each other? Do they feel that they can trust the infrastructure that they work on? It's really hard to figure out if trust exists, but I think the most straightforward way is just to ask the people and to hope that they are honest. And lastly, stay up to date. So keep in touch with the community. Good job, people. You are here, so you are doing that. Stay up to date with, for example, Slack channels like search and relevancy, or we are also part of the Vespa Slack. Read blogs, just see what other people are doing. I think we all can learn from each other to help each other to build the best features for our users, because I think that's the end goal for all of us. And the last learning that we want to give you is, do not underestimate your autosuggest. So you are the start of the user journey in autosuggest. So you really you can define the rest of the user journey. You can help the user to feel like welcomed from the first interaction with your platform. So you really have a high impact also on the metrics, but also on how the user will just see your platform. So this is what we wanted to show you. If you have any questions, we are really happy to answer them now, or you can come to us during the day. And I hope you learned something from our talk.
So thank you for your talk. So if there are questions, you can raise a hand. So we'll start from right.
Yeah, thank you. I was wondering if there were any kind of things that didn't work, or
A lot.
maybe shed some light on things you tried and where you thought it might have worked but didn't.
We tried, for example, filtered suggestions. So we automatically apply filters to search results, and we invested a lot here, but it didn't work out. This was a pretty good example we did. We also had a lot of iterations on clustering, so the clustering approaches to collapse the most similar queries. That was also a hard journey for us.
Thank you. Hi, great talk, thanks. You mentioned that you use Squirrel, a machine learning-based model for improving in the context of long queries. Do you have any metrics on how did it impact all queries overall, if there was a positive impact, and how did you manage to not have a negative impact in there?
So what we measure is that, or our application is that we really just apply it for the cases where we really need it. And measuring those cases, we see that it has really just a positive impact on the overall suggest, because now the user always gets some kind of response from us, which in all the metrics basically we saw a positive impact. And because we don't apply it for the other input where we can use the standard features, there was also no negative impact on those sides.
But maybe next year we can provide a talk of how we implement or how we migrate or integrate the bird model suggestions with the prefix matching, because this is pretty interesting.
So first of all, we also have a specially dedicated team for auto suggestions, so you're not the only ones. But my question is, you put the technical difficulty onto low, and that was a little bit of a trigger for me, because from our experience doing all the computations, like imagine how many pairs you have, all the queries, all the products, plus you build personalization on that, and that actually requires quite a lot of computational power. And for us, the only solution came in when Google, our cloud provider, rolled out the ML in SQL, and that was the only answer. So I'm really curious how you did solve this issue.
So you mean at the end, the bird model? Why the technical effort is low there?
Sorry?
The bird model at the end, we had the info that the technical implementation effort was low. That is your question? Why this is low and not extremely high? And also...
No. My question is how, what stack are you using to compute all the pairs?
So basically we're using Vespa, and Vespa is doing the whole stuff for us. So we are computing the vectors on when we are currently starting the instance. So we get the query. So we have a file where we store all the queries which are possible to be shown to the customer. And when we spin up the instance, we are computing these vectors. And in Vespa, it's pretty easy to configure this, and we need to switch some AW instance to a higher level, but basically the technical effort was pretty low there. So
if you're interested, we have backup slides I can show you later.
yes.
Hi. So you talked about autocomplete effort for the users, right? So you talked about prefix length and you talked about click position, which was your intent of showing the best suggestion on the top. How do you optimize between both of them? For example, I can show the best suggestion on the top if the user has typed a complete query, but the prefix length is really high. We had done an experiment wherein earlier we used to show the best suggestion at position 3 when the prefix length was 1, but then we stopped showing it and the click position went to 1 because the prefix length increased. So how do you optimize between click position and prefix length in these cases?
We actually just try to show the best one that we think is fitting for the input that you have at the top. And oftentimes, I mean, it's really the one that the user wants. Then if you continue typing, it's still at the top right, because then the prefix will still match. But other than that, we don't really check any inference between the prefix length and the suggestion. So we just look at your current step in the journey, because we basically hope that you will not type anymore because our result is already good enough. Does that answer the question?
I have follow-up. I will talk to you.
Okay.
Hey guys, great presentation. Thank you for that. And Tom, you're always great and delightful to see. So thank you for this.
Thank you.
Question I have for you, I'm really curious. Like, so when you were showing the searches and things like that, some of them are in full sentences, right? I'm wondering how much of this really happens. Like, how much of this do customers actually do? So, for example, when I shop, I just say t-shirt. I'm not going to have a conversation with my search bar and things like that. So I'm wondering about when natural language comes in, how many users are actually conversing with their shopping? Because I think this is such a new phenomenon as well. This will come. But right now, customers just go in, they're very categorized in what they're thinking. I need t-shirt versus shoe. So they're going with categories. And so therefore they're just going with the key phrase rather than have a conversation with their search bar. So I'm just curious if you can comment on that.
So we don't have that many. It's still a quite very small segment, but we already see it in our, like when we see what queries we get. And interestingly, it really sees like, so we have an app and the app supports speech to text. And we really, there are really queries, they start with hello, so hello, and sometimes even hello Otto, and then the user says what they want. So it's already occurring in the verbal way of communicating, maybe because it's just comes natural to the humans. When you start talking, you don't just tell me keywords. And we don't really see it that much in the really typing out, but that's the interesting part for us. That's why we wanted to try out this model integration, because we wanted to see, hey, if this will happen in the future, and I mean, it doesn't sound so far-fetched, right? That's why we wanted to try out how can we prepare for the future already? What options do we have? So that's why we thought, hey, it's low effort, so why not just see what happens? What Uwe says. Oh, he says that the users copy for ones that didn't hear him. So they copy paste stuff from other sites.
First of all, I really love the staged approach. I think this is exactly the right way to handle, let's say, the 90% by the normal cheap stuff, and then tackle the rest afterwards with the more complex stuff. The question I have about, let's say, the more complex model is, since it might already be, let's say, a longer time in production, were you facing model drift or something like that? So that the model initially produced very good results, but then later it kind of diverged.
So we're currently testing a lot out, and we are regenerating the model, let's say, every twice a week. So we are currently not in that topic of drifting away, of a model that is drifting away, but we need to invest into this topic in the next months. Yes.
But important addition, that's the light GBM model for re-ranking. The model for retrieval, we didn't invest anything. It's just the plain pre-trained version that we got. So there we see it just works without any effort. So there's a distinction between those two models.
Yeah, because from my experience, new brands come up and something like that, and then the model thinks, hey, this is a color, but in reality, it's a new brand.
Yeah, exactly.
That's what I mean.
Yeah.
So thank you for your questions. Thank you for your talk. It was a wonderful discussion.